Okay, so I just wanted to introduce how Java is actually working, just to walk you through if you're having questions or unsure exactly what's going on with all of this. So here in our Java main, we're doing a couple of imports. The scanner that allows us to be able to write from the keyboard, we have to be able to tell the computer that's what we want to do. Calendars for the minute calc, and so there's some date stuff that we're doing. So that's the reason for that import. Um, our class is called main. That's a pretty basic class, and then here are all of the methods that exist in this class. The main thing that we want to do is we want to be able to have a public static void main. All programs have that somewhere. Guess there's some action going on. And so this is known as the driver. This is what is going to be running our program. In this particular method, I've got all the calls to the different methods commented out. And what happens when I click on run, it's going to find main, and it runs all the code from the open curly brace to the close, and that's it. It's just that when we call some of these methods here, the byte tester, int tester, double, and minute calc, it leaves main and runs these other methods. So I've got one line. I'm just outputting hello world. So when I click on run, it's going to find main, run system out print line, output hello world, and then all of these other lines are commented out. So it gets to the close curly. This program is done, and the only output that I've got is this guy here, hello world. So I know that my code here is working correctly. Main's working. I didn't have any syntactical errors in setting it up. So now I'm ready to do byteTester. So here is my byteTester code. And again, so what that's going to do is when main is called, byteTester gets called, all of a sudden the flow of control leaves main, bumps down here, and starts to run this code. So this is what we've done previously over the last few days. We create a variable called num. We set that to 0. We're initializing this variable at this point. We're assigning it a value for the first time. And when we do that, when we declare a variable for the first time, we have to identify what type of data goes in there. That is true for all variables. The names can be anything we want. Single equal sign is assignment. I'm going to assign a value. I'm assigning that to 0. Semicolon marks the end of that line. That's not what I want to do. And then here's a comment that is explaining what's going on. I'm doing a similar thing with another variable. I'm calling this one count. It's an integer instead of a byte. I'm initializing that also to 0. And we're off to the races. What I wanted to do is show you that those numbers flip. You've seen me do that in class. So I have a while loop that exists here. You'll notice that I've got these semicolons at the end of int and byte, those byte variables, those two variables. I don't seem to have one here at the end of my while loop. And the reason for that is that this is not really a full sentence. Think of that as a subordinate clause in an English class. While this is true, what you want to do something else. So putting a semicolon here, it will still compile at that point, but it means that don't run this code, and it will run line 20 and line 21. It's just that it would only run them one time. So that loop, that is problematic if I were to do that. So what I really want it to do is I want it to go inside of this loop. That means that at the end of this line, there really is an open curly brace. I like putting the curly braces in line with one another, it means that it's a lot easier to see that, oh, I've got an open and I got a close. So some of you have had issues with an error that says end of file while parsing, or enum or class expected. And that's a curly brace problem. Either you have too few or too many. And so if you put these curly braces in line with one another, visually, it's a lot easier to see where the start and where the end actually is. So because this is not really a full sentence yet, it's not really a full line. There is no curly brace. No, I'm sorry, there is no semicolon. There is a curly brace, and now we're going to be running these two lines in this while loop. Right now, we're saying while true. That means that it will always be true. This is currently, it's an infinite loop. And you've seen me do this in class. That runs, and all I get is those numbers that are toggling back and forth between positive and negative values that we're increasing one on each side. You can see those numbers are going up by one until they get to 127. We add one to that. That flips the negative bit to a 1, and all of a sudden we're at negative 128. We start counting up to 0, and then that becomes positive. So moving on, if I wanted this to stop, let's say I want to, I'm going to put some question marks in there. So while some condition is true, I still want to add 1 to num, and but I want to utilize this count. Maybe I want to cycle through those numbers 4 times. I want to see it go positive, negative, positive, negative, positive, negative 4 times, and then I want it to stop. So I'm going to utilize count as my way of doing that. In other words, every time num equals 0, I'm going to increment count by 1. All right. So I'm going to keep looking through those numbers. I'm going to add 1 to it, and then, hey, by the way, check, is it equal to 0? And if it is, I want you to increment count. So I want you to keep doing that while count is less than some value, say 4. And so if I did that, if I change that to while count is less than 4, well, count is initialized as 0, so this is going to be true on the first time. If I don't do anything in here, count is going to increase from 0 to 1, and then 1 to 2, and 2 to 3, and 3 to 4. Finally, when count is equal to 4, well, 4 is not less than 4, so this while loop is now false, and it kicks out. So it doesn't, when count is 4, it doesn't run this code. It bounces to this last curly brace and says, okay, what am I supposed to do now? And that's also the end of my method, and it comes back up here and is done with it's done with byteTester, it's done with main, and it ends. Were I to run this method now, what I would discover is that I'm not changing count anywhere in here. So this is another infinite loop. All right, so count, I'm not changing count. And so as a result of that, count will always be 0, and the same thing would happen as if I put true. So what I'm going to do instead is I want to do a test. I want to say if count, if num equals, notice that's a double equals 0. That means it's cycled all the way through. It's not quite where I want to be there, buddy. Not sure why it's not nice and pretty the way that I like it. So if that is true, if num equals 0, I want count to increment. So I'm going to assign count to its current value. I want you to add 1 to it. Now I put spaces in there so that it's easier to read. That is, Java ignores white space. You don't, that's not a requirement. So now every time that I go through here, um, count is going to go up every time that it is equal to 0, and eventually it's going to stop. So we'll run this. And I think it went through, and eventually it did. There it goes. It goes to, and it stops. I think one of these, there we go. We'll clear it. We'll run it again. So notice that it did stop. And I can go through here, and sure enough, it did from the very beginning. There it is at the start. Starts at 1. Why does it start at 1? I thought it was at 0. It's because in the first time in our loop, we're incrementing it by 1. So the first print, it's actually outputting 1, not 0. Um, then I'm going to be doing this test, and it waits around until it finally goes negative and comes all the way back. Then count goes up, and eventually that stops. One last thing that I'll point out on this line: this is known as casting. The problem is that num is a byte. 1, this guy here, that's an integer. I'm adding a byte and an integer together, and those are two different data types. Then I want to store that back into another byte. The problem is that if I add a few bytes of data with a big byte of data, it will convert it into the larger size. So by adding num plus a byte with an int, this is suddenly going to become an integer. When I store that back in num, that's when it says, well, wait a minute, I'm an integer, I'm not really a byte. So I'm forcing this data to be this num plus 1 back to be a byte. And so that's forcing it to stay very, very small. So that's known as casting. I'm taking some data, I say I know what I'm doing, and I want you to remain a byte in order to do that. And there you go. So that is the byteTester, an introduction to main and the byteTester class.